Hello students, welcome to Educate. Today we are going to study next chapter of physics, class 11th. Chapter is motion in a plane. We have already studied in lower level the scalar and vector quantities. Scalar means a quantity that has magnitude but not direction. Direction, no. Magnitude, yes. Example, when we talk about mass, so it has magnitude but its direction is not certain, means it has no direction. Another, suppose we take speed, so it has magnitude but no direction. Distance, it has magnitude but no direction. So such quantities are called scalar quantities. There is another quantity that is called vector. So vector quantities must have both things, magnitude and direction. When we say 4 Newton force, so we have to mention the direction along with the magnitude. Similarly, if we say 3 Newton weight, so if it is representing weight will act downward. Similarly, velocity, it has certain direction, displacement has certain direction. So such quantities will be called vector quantities. Same thing is written here. A scalar quantity has magnitude only without any direction. Scalars are described by just a numerical value and a unit. Example, temperature, say 25 degrees centigrade. Mass, 10 kg. Time, 5 seconds. Speed, 50 km/h. Here, one thing related to English I am going to tell you. Do you know what is the meaning of EG? You generally say EG means example or for example. Why? Have you ever wondered? If you say for example, so its short form will not be EG. Or if you say example, still its short form will not be EG. Then why do we write EG? The rule is very simple. Here, this word is short form of Latin words EXEM GRATIA, exempli gratia, which means for example. This is English equivalent. So whenever we write EG, it means we are going to use Latin word. Similarly, you must have seen sometimes we write IE, I.E, and we read it as that is. Why so? So the reason is very simple. It is short form of id est, which means that is. So this will be helpful for you in English. You must know about it. So here we have studied the concept of scalar and vector. I am going to further elaborate this concept. So vector quantity, a vector quantity has both magnitude and direction. Vectors are represented by an arrow pointing in the direction of the quantity and having a length proportional to its magnitude. Some examples, like when we say 5, suppose we want to write say some quantities like say vector A. So here this arrow indicates that it is a vector. We will study the components and other things, how to evaluate, etc. So here the same thing is given. Some examples are like displacement 10 meters toward east, velocity 20 meters per second toward north, force 50 newtons acting eastward, acceleration 5 meters per second squared directed downward, etc. So here in every quantity you will see, or you just see that direction is associated. So we say that such quantities are called vector quantities. So you have seen the difference between scalar and vector quantities. Now we are going to see what is the notation of vector, what are its components, and then we will see other related concepts. So whenever we want to write a vector, then we write some unit vectors. So unit vectors along 3 axes. Along x-axis we write I cap. Along y-axis we write j cap. Along the z-axis we write k cap. So whenever we write any vector, suppose we write vector A and we write 2i cap plus 3j cap plus k cap. Here the component of vectors are 2 unit along x-axis, 3 unit along y-axis and 1 unit along z-axis. So you have seen that any vector has components along x-axis, y-axis, z-axis, and we can find the magnitude of the vector. So in order to find out its magnitude, we write vector A modulus, or we can just write plain A. Here plain A will indicate that it is its magnitude. Now in order to get the magnitude, what do? We write 2 square plus 3 square plus 1 square. So this will become 4 plus 9 plus 1, which is root 14. Now here we can find a unit vector, a vector whose magnitude is 1, but it is in the direction of given vector. So for that we write A cap. A cap means given vector divided by its modulus. So here we are given a vector, suppose this, or we can take from here vector A equal to 2i plus 3j plus k, and we want to find out unit vector in its direction. For that purpose we write A cap equal to vector A divided by modulus A, and vector A is same, so you can write it as 2i plus 3j plus k and divided by magnitude of it, that is root 14. I think you have understood. Now this topic is very interesting and you will enjoy it. So we have seen what is unit vector. Now there are some practice questions for you. The questions are: find a unit vector in the direction of vector A, where A is given as 4i minus 3j plus 12k. Here we have vector A equal to 4i minus 3j plus 12k. You have to write k cap, I cap, j cap. So this is given vector. In order to find its unit vector, we need vector A divided by modulus of vector A. So vector A is already given. We need modulus A. So for this purpose, we proceed like this. So 4 square plus, we don't write negative sign, 3 square plus 12 square. Whatever value you are getting, just write 16 plus 9 plus 144. Then find the sum. So here this will become 160, 169. So it will give 13. So you have got the modulus of vector A as 13 and vector A is this much. So you can write 1 upon 13 times this vector. There is another question. Find a unit vector in the direction of A equal to I cap minus 10j cap plus 2k cap. Same thing you can do here. Just take vector A, I cap minus 10j cap plus 2k cap. Now you have to find out modulus of vector A. For this, just write the squares of sum of squares of coefficient. So 1 square plus 10 square plus 2 square. So 1 square is 1 plus 100 plus 4, this is root 105. So A cap is vector A divided by modulus A. So just write the values. So vector A is given vector I cap minus 10j cap plus 2k cap divided by modulus A is root of 105. So this is the answer. So you have understood. Now some more definitions, let's analyze. Fixed vectors. A fixed vector is a vector whose initial point is fixed at a specific position in space. The direction and the magnitude of the vector are independent of its initial point. Example include displacement vector, force vectors, etc. So one point is fixed and then it can move in any direction. Now free vectors, a vector that can be moved from one place to another. A free vector is a vector that can be moved parallel to itself to any point in the space without changing its direction. Keep in mind, two things will never change, direction and magnitude. Even if it is movable, but direction and magnitude will remain same. Free vectors are often used to represent forces, velocities and displacement. They are characterized by having only magnitude and direction, not a specific location in space. The main point is, since it is free, so fixed location can't be there, like in case of fixed vector, where the vector is fixed, it can't be moved. Now collinear vectors, two vectors in the same direction. So collinear vectors are vectors that lie on the same straight line or parallel to each other. They may have the same or opposite direction, but must have the same or proportional magnitudes. For example, so suppose you are given a vector, say vector A equal to 2i plus 3j plus k, and if you just double it, so what do you get? 4i plus 6j plus 2k. This will be a collinear vector. If you change the sign, suppose vector A is this, suppose we write another vector, vector B equal to minus 2i minus 3j minus k. Or you can observe here also, vector A equal to I minus 10j plus 2k. Here, vector B is with changed sign, so they are collinear. Then coplanar vectors. Coplanar vectors are vectors that lie in the same plane. They can be represented by arrows drawn in the same plane, and their tails and heads can be connected by parallel lines. For example, you are given vector 2i plus 3j and vector B, this are coplanar if the plane lie and includes the origin. If they start from same point in same plane, here suppose you are considering xy plane, xyz plane, etc. So that we will study in detail later on. Now next thing is there, co-initial vectors. Co-initial vectors means the starting point must be same. Here three vectors are shown, vector A, vector B, vector C. So here these three vectors will be co-initial vectors because their starting point are same. So definition is given, co-initial vectors are vectors that have the same initial point or tail. They can be added or subtracted by connecting their heads and then drawing a vector from the common tail to the tip of the resultant vector. So later on we will study operations on them. These are just definition. Coterminous vectors. Coterminous means ending at the same point. Here there are three vectors shown. They all are ending at this point. So we say that they are coterminous vectors. Zero vector, a vector whose magnitude is 0 and it has any arbitrary direction. Then comes scalar multiplication. Scalar multiplication means you are given any vector in terms of its components, as you know, and then we can multiply by some number. Then what will happen? I, j, k will remain same, only the magnitude will get multiplied by that number. Example, here Suppose you take vector A equal to 2i plus j plus k. If you write twice of vector A, so this will become 4i cap plus 2j cap plus 2k cap. So what will happen? Its magnitude will change by factor of 2, as you have seen here. Now, triangle and parallelogram laws of vector addition. We are going to see how to add the vectors by using triangle law or parallelogram law. Here, this is one vector and this is another vector. We have to find out its resultant. So let's see how. Suppose this is one vector and another vector is like this. So here it is terminating, another vector is starting from here. So resultant of these two vectors, suppose it is vector R. This is say vector A, this is say vector B. So what do? We can draw a line like this till here and then we draw perpendicular. And then in terms of this B, suppose this angle is theta, so we can write this as B sine theta, isn't it? This is hypotenuse, this is perpendicular, and this will be base, which will be B cos theta. Now we have a right angled triangle like this, in which this angle is 90 degree, this is B sine theta, and base has become A plus B cos theta, and this is say vector R. So here I am writing it in terms of magnitude. Now we can apply Pythagoras theorem to get a resultant. So R will be equal to root of A plus B cos theta whole square plus B square sine square theta. So if we open the bracket, we will get A square plus B square cos square theta plus 2AB cos theta plus this term B square sine square theta. Now this B square cos square theta and this B square sine square theta will become B square. So what do we get? Then resultant that we are going to obtain will be R equal to root of A square plus B square plus 2AB cos theta. Now, as you have seen that this is first vector, this is another vector, second vector, and this is angle between them, theta. And the resultant is here. Now suppose you want to find out this angle, say this is beta. So it is simple, as you know, up to here it is A plus B cos theta, and this perpendicular distance is B sine theta. So we can find tan beta equal to perpendicular B sine theta divided by A plus B cos theta. I think you have understood. We will do some numericals, then thing will become clearer. The same thing is explained here in this diagram. If you observe, from here to here vector A, from here to here vector B, angle between them is theta. Why? Because this is in this direction and that is in this direction, so this angle is theta. This is direction of resultant, and this is the angle that resultant makes with first vector. Here what we have done, vector B is written in terms of perpendicular and base components. So this will become B sine theta, this will become B cos theta. So total from O to N, it will become A plus B cos theta, and perpendicular is B sine theta. Then you can apply Pythagoras theorem, as this angle is 90 degree. So we can write OB square, hypotenuse square, equal to ON square, the base square, plus NB square, perpendicular square. Now we put the values. So we get r square equal to a plus b whole square, sorry, a plus b cos theta whole square plus b sin theta whole square. Then we simplify. So this will become r square equal to a square plus b square plus 2ab cos theta, or r equal to a square plus b square plus 2ab cos theta square root thereof. And as I told you here, if angle is alpha, so perpendicular upon base, so tan theta, not theta, but tan alpha, so b sin theta divided by a plus b cos theta. Now we are going to do some questions to make this concept clear. Here the question says, if two vectors of magnitude 8 units are inclined at 120 degree, then find their resultant and also find the direction of the resultant vector. You are given, this is vector of magnitude 8 unit, another vector has also magnitude 8 unit, and angle between them is 60 degree, 120 degree. So situation should be different. This is vector A, and if you want to make 120 degree, so another vector should be like this, because it has direction this, it has direction this, so this angle will be 120 degree. We have to find out resultant. So what is resultant? So it is simple. We can write the formula as we know, a square plus b square plus 2ab cos theta. Here a is 8, b is 8, so 8 square plus twice of 8 into 8 cos 120 degree. And if you remember, cos 120 degree is same as what? I'm going to tell you how to get. Suppose you want to get cos 120 degree, and this is question in your mind because you have studied till 90 degree. So I'm going to elaborate the same concept how to get degree values beyond a certain value. So like if you remember, when we have learned 0 degree, 30 degree, 45 degree, then 60 degree, then 90 degree. But beyond that, you have not studied. So for going beyond that, I'm writing here so that it may become clear. Suppose 90 degree is line of symmetry. So here 60 degree, there is gap of 30 degree. Here you write 120 degree. Then here there is 45 degree. So gap of 15 degree. So it will become 135 degree. Then 30 degree. Then there is gap of 15 degree. So here it will be 150 degree. This is symmetry. Then 0 degree, there is gap of 30. So gap of 30 will be 180 degree. So these are the values. Now, if you remember, when we write sine theta, so for sine theta we use 0, 1 by 2, 1 by root 2, root 3 by 2, and then for 90 it is 1. After that there is symmetry. If you remember, the graph of sine theta is like this. Here the highest value is 1. This is 90 degree. Now at this point, if you write 60 degree, so at this point it will be 120 degree, equal gap. So here these two values will be same. This is root 3 by 2, so this will also be root 3 by 2. Similarly, if you move back, suppose you come to 45 degree, similarly you move ahead by same gap, 15 degree, 60, this is 45. So here just add 15 to get 135. So these two values will be same. Sine 45 is 1 upon root 2. So here sine 135 will also be 1 upon root 2. Similarly, if you take sine 30, here this is 30 degree, you write 1 by 2. So corresponding value here will also be 1 by 2. But since there is gap of 15, the same gap should be here. So this will be 150 degree. This is 0, this is 0. So sine 180 degree will be 0, but sine 30 is half, and corresponding value is sine here 150 is half. So like this we can get, later on we will analyze Similarly, in case of cos, let's see what happens. The graph of cos theta, if you remember, at 0 degree it will have highest value, then it will start decreasing, it will go like this. So I'm not drawing the complete graph, just 0 degree, then this is 90 degree, here it will be 180 degree, then 270 degree, etc. So here we are going to see this symmetry, 0 degree, and here this is here this is -1. This value corresponds to -1. This value corresponds to 1. Then comes division. If you remember, you write general 30 degree, then 45 degree, then you write 60 degree. With the same gap, you can write here. There is gap of 30, so here you just write 120. Then this is 135. Then here 150. Now, if 60 degree is 1 by 2, then here 120 degree will be -1 by 2. Here 45 is 1 by √2, so here 135 corresponds to same value, so this will be -1 upon √2. Similarly, if you take 30 degree, √3 by 2, so here 150 degree will be -√3 by 2. So this is how we can get the different values of sin theta, cos theta, etc. The same thing is to be applied here, and after putting cos 120 degree as -half, you will get it as 8, because 8 square plus 8 square plus 2 into 8 into 8 into -half, then -half will cancel this 2, negative 8 square will be left, so 1 8 square will get cancelled and we will be left with 8 square, that gives 8. So you have understood. Now second point is to get the angle that resultant mix with base vector. So for that, what should we do? So let's see. Now, here angle between two vectors, as I told you, it is given as 120 degree, and we have to find out the direction of resultant. So formula is, we take sin theta component of perpendicular vectors. So let's analyze it like this, so that thing may become clear. When this angle is theta and this is say beta, so when we want to find out beta, so we take its, say this is vector b, so this is b sin theta, and this is b cos theta, and this is vector a. So in order to find tan beta, what do? We write perpendicular component b sin theta divided by a plus b cos theta. The same thing we can do here. Our concern is to get tan beta. So tan beta, we write 8 sin 120 degree divided by 8 plus 8 cos 120 degree. Now, sin 120 degree, as I told you, there is symmetry. So it is same as sin 60 degree. You have observed it here. This is 60, this is 120. Both are same. √3 by 2, √3 by 2. So you can write here 8 into √3 by 2 divided by 8 plus 8 into cos 120. As I told you, as I have shown you also, it is -half. Then we can evaluate the overall. So we get √3. So we have got tan beta or tan alpha, whatever angle we use. Suppose we have taken tan beta and we have got √3. If you remember, at 60 degree, tan theta gives √3. So beta equal to 60 degree. So this is the angle that resultant vector makes with the base vector. Now we will see some more questions. Here we are given two vectors whose magnitudes are in the ratio 3:5 are inclined at 60 degree. If their resultant is 35 Newton, then show that their magnitudes are 15 Newton and 25 Newton respectively. How will you solve this question? Here, suppose the vectors are, first vector you take suppose x, sorry, ratio is given, so 3x and 5x, just write 3x and 5x, and theta is given as 60 degree. Resultant is also given as 35. Now you can apply the formula. What is formula for resultant? Root of a square plus b square plus 2ab cos theta. Now resultant is 35 equal to root of a square. So square of 3x, that is 9x square plus 25x square plus twice of 3x into 5x into cos 60, that is 1 by 2. So what do we get? 2 will cancel out. 35 equal to root of, here 9x square plus 25x square will become 34, and here this is 3 into 5, 15. So it will become 49x square. So 35 equal to 7x. So this gives x equal to 5. We have got the value of x as 5. So since we have taken the vectors as 3x and 5x, we multiply by 3, to this value. So this will become 15 and this will become 25. So answer is 15 Newton, 25 Newton. I think you have understood. Now let's proceed with the next question. Here, next question is, two forces x and 2x are acting on a particle. Now, if x is doubled and 2x is increased by 20 Newton, their resultant force remains the same. Show that x equal to 10 Newton. So here, you are given two forces. One force is x, another is 2x. Two forces x and 2x are acting on a particle. Now, if x is doubled and 2x is increased by 20 Newton, so their resultant, suppose resultant will be how much? Root of x square plus 2x whole square plus twice of x into 2x into cos theta. This is initial resultant. Now, in our question, it is given that if first force x is doubled and 2x is increased by 20, so this becomes 2x and the second one becomes 2x plus 20. Then resultant does not change. They are saying then the resultant remains the same, so that x equal to 10 Newton. So we can proceed, we can find the resultant of these two also, and then we can equate to get the answer. So resultant of these two will be 2x square with under root 2x square plus 2x plus 20 whole square plus twice of 2x into 2x plus 20 into cos theta. Here Angle is not changed, keep in mind. Cos theta remains same. Since the resultant are same, so we can equate the two forces, sorry, the resultants of two cases. So I am writing both things together. So what you can do by squaring the resultants in the two cases, so it will be x square plus 2x whole square plus twice of x into 2x into cos theta must be equal to, first one is doubled in as written in the question. Now if first one is doubled, so if we make it 2x, so it will be 4x square plus second one becomes 2x plus 20 whole square plus twice of, first one is 2x, second one is 2x plus 20 cos theta. Now we can simplify this to get the value of x, and that will come out to be x equal to 10. This is your work, you can do. If there will be problem, we will discuss. This question can be solved by another method also, but you will try first by this method. I will tell you later on. Next question is, the sum of the magnitudes of two forces acting at a point is 18 Newton and the magnitudes of their resultant is 20 Newton. The sum of magnitudes of the two forces acting at a point is 18 Newton. Suppose two forces are, say, A and B. So sum of their magnitudes is given as 18 and the magnitude of their resultant, say it is R in terms of magnitude, is given as 12. Now, if the resultant makes an angle of 90 degree, so here beta is given 90 degree with the force of smaller magnitude, then so that the two forces are 5 Newton and 30 Newton. So suppose this is smaller force, suppose this is A and this is another force, direction of resultant is 90 degree. So suppose this is another force, so, and the resultant is like this. I'm rewriting so that thing may not become wrong. So you know tan beta is given as perpendicular component of second vector. Base vector we are taking A, which is smaller one. So base vector we will write here A plus B cos theta, and in numerator we will write B sin theta. Here value of resultant is given, that we will use later on, but before that tan beta means tan 90 degree equal to B sin theta divided by A plus B cos theta. Tan 90 is not defined, but here we have to write it as 1 upon 0. So when we write 1 upon 0 equal to B sin theta divided by A plus B cos theta, we get A plus B cos theta equal to 0 because this will get cancelled. So we will get one relation, A plus B cos theta is equal to 0. We have got one important point by using the value of resultant. Now, we use the concept of resultant. So R will be equal to root of a square plus b square plus 2ab cos theta. Or we can write r square equal to a square plus b square plus 2ab cos theta. Now, r is given as 12, so this will become 144, and we can do one thing. Here we can get the value of b cos theta. So if we take the value of b cos theta from here, so in place of b cos theta, we can write minus a, because this a will get shifted to other side and it will change its sign. So we will get a square plus b square minus 2a square. Is it clear? B cos theta is replaced by minus a. So when we write here minus a, this will become minus 2a square. So from here we will get 144 equal to b square minus a square. This is second equation. Now we have two equations, a plus b equal to 18 and b square minus a square equal to 144. Now here what you have to do, you will get the value of either a or b. A equal to 18 minus b. Now put this value over here and evaluate. So 144 equals b square, and we are putting the value of a. So b square minus value of a is 18 minus b. So 18 minus b whole square. Now we open the bracket. 144 is equal to b square minus, this will become how much? 18 into 18. That is 18 square minus b square plus twice of 18 into b. So b square will cancel out. This number will be shifted to that side. 144 plus 18 into 18 is 18, sorry, equal to 36b. Then from here you can get the value of b, that is your work, and then from that equation you can get the value of a. So that is your work. I think you have understood. In this lecture we have stopped here. We will continue the next questions, and I think you have enjoyed. Thank you, Team Educate.